A microscope is focused on a mark on a piece of paper and then a slab of thickness 3 cm and refractive index 1.5 is placed over the mark. How should the microscope be moved to get the mark in focus again? So let us assume we have this paper on which an ink dot is there. We are using a microscope here and we see the ink dot. Now in between the microscope and the ink dot, a glass slab is introduced. Now what will happen? Due to the refraction, this dot will appear to be raised. Okay, so we will not see its actual position. So here let us assume the ink dot is here. Okay, and on placing the glass slab of thickness 3 cm, what will happen? Its a real depth is 3 cm. Means from this surface it is 3 cm down. But due to refraction, we will observe it here. Okay, that is we observe it shifted and we observe it at some apparent depth, not the real depth. Now we have equation apparent depth is equals to real depth by refractive index. So the real depth of the glass slab is 3 and the refractive index is 1.5. So the apparent depth is 3 cm. That is the object or the ink dot which is here will appear 2 cm from the surface. Okay, and that we call apparent depth. So it will appear 2 cm from the surface. So it is observed 1 cm shifted because the total thickness, the total apparent, the total depth, that is the real depth is 3 cm. But we are observing it at a distance of 2 cm. Means the ink dot is shifted by 1 cm. Okay, upward. So we have to shift the microscope by 1 cm upward. So to make it focus again. So the normal shift is real depth minus apparent depth, that is 3 minus 2, 1 cm. So as the image appear to be raised by 1 cm, therefore the microscope must be moved upward by 1 cm.